I haven't.
I've used his Lua library actually.
Oh, that's funny. I've only ever written Lua. Like, it's been years. I have not played World of Warcraft in years, but their add-ons were in, or extensions, whatever they were
Isn't that
called.
what Vim, like NeoVim's in Lua? So I think I've only written enough to different clients.
In theory,
But I don't know what I'm doing
Okay.
I'm double checking because I don't actually see it showing up. Okay, there it is.
And then you have another.
Now I see it showing. I do not see it showing up on Twitch.
And then I was like, oh, this is still enough. So my
Okay, now it's showing up on Twitch. Cool. All right. So I'll go ahead and kick things off, and we just won't have your face for a few minutes until this charges enough to.
That's okay. This is my first tech talk. Nobody needs to see me sweat.
Hey, how are you?
Oh,
Glad to hear that.
But it's fun. I enjoy it.
All right, well, let's go ahead and get this party started. Thanks for being here. Glad we had some time to eat pizza and chat, except you didn't make it time for the chat, but there we go. So let's see, orders of business. Just go around the room and do names real quick. So we'll start with me. I'm AJ. I host this thing. I don't really know much about Zig yet, but I used it once and it was phenomenal, and I want to use it again and again and again. It was enough that I was, well, I've seen the vision. I'm bought into the dream. All right, and then we've got
Niles Walter. I love Zig. I gave the last talk last month. It was really great.
and it is recorded on YouTube. If you want to, anybody wants to grab that to see
All right.
it was on the history.
All I heard was my name's mouth full of.
Yeah, sorry. He asked me a question while I was eating. Yeah, he loves doing that. Yeah, my name is Niles Salter.
Okay.
And yeah, I gave the last talk last month. It's on YouTube if you want to watch it.
I actually was watching it at home. I meant to come, but I was feeling sick that day, so I didn't end up actually getting here.
Yeah, I've been working on part 2, so.
I've still got to re-upload that to the Zig channel because that went to my personal channel. Tonight we're on the Zig channel.
Awesome.
For both Twitch and YouTube, we are now officially on the Utah Zig channels.
Yes.
From
I still want to ask about the warehouse job. That was actually
Yeah.
funny to me when you said that.
Yeah, I'm a funny person.
I'm like, you're doing like deep levels in. Like, I work as a barista. What? Like,
and we'll
Yeah.
circle back around to that.
Yeah, I mean, yeah, honestly, it's just like, I don't know what to say. That's, it's just like, that's what I like to think about, you know? I mean, other people do other things, I just like to, like, think about Sydney, so.
oh,
I know.
I enjoy programming,
Yeah.
and I made it my job, and now I regret it because sometimes I'm like, well, that's what I do for fun.
Right.
And now, what do I do for fun? Like,
Aquariums, man. You're gonna come over on Saturday. We're gonna have a blast. You're gonna leave with your own 10-gallon tank. You've not seen me on Tetras before, have you? They're so beautiful. Anyway.
Yeah, one time I talked to a magician when I was in elementary school. Came to the school and he was like, yeah, you know, I used to love magic, that was my hobby, now it's my job, now I need a different hobby. So, yeah.
That's smart.
I'm Nathan. And I do lots of things with Zig.
No, said. We'll learn more about that later.
Jojo, I do almost nothing with Zig, but I'm Zig curious.
That's right. That's right. I met your new face.
Yeah, new. Ryan, I just ran into Zig over Christmas break and had fallen in love with it pretty quick. I've been doing it like programming every night after work with Zig. So.
What drew you into it?
I started looking into Rust a little bit, and then someone at work just had mentioned Zig sounded interesting. So I started looking at Zig and just liked it a lot more than Rust, just from like a faraway view. It was more attractive. So I did the like Ziglings course, which was awesome, and then I just started writing like a 2D game engine in it, which is going super slow, but I'm learning a ton while I do it.
Right. That's fun. Do you, what do you start with for like a 2D engine? Like, what are the primitives that you want to build up for that?
Oh, I don't even know. Right now I'm mostly trying to lay, like, I just got like a screen up and going, and I'm just like kind of laying down, learning how to do, because I've just done Kotlin and Java my whole life, so just kind of learning how to do abstraction in a language like Zig, which has been, so I've just tried to like abstract out like the platform and rendering and stuff right now. So I haven't even really got into any of the nitty gritty of the rendering,
Okay.
but I think it'll.
Do you miss having to type everything in triplicate into? Oh, that's just what I imagine.
All right. Well, thanks everybody for the introductions. And now we're going to go ahead and say thank you to our sponsor for the room and the pizza. That is Vivint. They do hire a variety of positions. Jeff and Travis are not in the room tonight, and they do not have any Zig positions yet. But you could get in with like the Rust folk or the Go folk, and then like zigzag a little, and yeah, make it. They do device stuff and some
Zigzag
things.
your way to Zig.
Yeah, exactly. Anyway, so they're not in the room tonight. I think Jeff is actually over in the Rust room. Rust is having their meetup right here. So if anybody gets bored and wants to switch, we will look the other way. And then our speaker tonight is Andrew Gossage.
That's correct.
And you're going to be doing an introduction to low-level polymorphism in Zig. So let's give him a warm welcome and then let him take it away.
Thank you.
Oh, and you can interrupt at any point with questions. That's house rules.
How dare you? No, of course. Okay, a little bit of who I am. I'm a freelance back-end developer and data scientist. I work mostly with small businesses. I did do a little bit of work for NASA. That was fun. Father of 3. I've been programming professionally for 2 years if you don't count my time as an indie game dev. I have my GitHub and my Twitter there if anybody's interested. And today we're going to talk about polymorphism. Does everybody know what polymorphism is?
Ish. An object-oriented concept, I think, where, actually I don't want to say it.
No, of course. It does exist in non-object-oriented paradigms as well. FP has the concept of polymorphism. But basically, it's the idea at a super high level that you can treat multiple types of data as if they are the same type. There is a significantly more formal definition for it that gives more information and more restrictions, but that is essentially how it works. So we're going to go over a scenario for why we might want to be able to treat multiple types as if they're the same type. And we're going to go over a few different methods to do that at a low level, specifically in Zig. So here's the scenario. Imagine you are building an indie game, which is what everybody does when they first start programming. So it should be familiar. Let's imagine, though, that you're part of a team and you have been tasked with developing a system for managing enemies in this small game. And ideally, your code should be readily readable and usable by other people. You're going to have to be able to pass around these enemies to different parts of the program. So let's look at a struct in Zig, which is Zig's way of declaring a type or a class, although the word class is verboten in Zig. So this is a basic enemy. It's a goblin, has an x and a y coordinate, has an init method, which is the Zig equivalent of a constructor, an update, an attack, and a draw. The specifics don't actually really matter all that much.
So does init get called automatically like in JavaScript?
It does not. You have to call it automatically. Sorry, you have to call it manually.
Okay.
Yeah. Actually, the next slide has an example of that, calling it on something called an array list, which is the equivalent of a C++ vector, basically, or a list in Python. Oh, I have a typo there. That's supposed to be one goblin and one ogre, but
You got uppercase forwards as well.
yep, I'm just sloppy now.
Dude, there's totally a way to fix that in the settings of Google presentation. Is that what this is?
No, I'm using OpenOffice, but
There's still a way to fix that. You can turn off the smart quotes and the auto caps and all that stuff.
anyway, so we won't worry about fixing it. Just pretend it's right. There's probably going to be some more mistakes today. This is the problem with a basic struct in Zig. It is monomorphic, meaning it is not interchangeable with any other types. There is a little bit of an exception in that when you call a function on something, you can use any type, which is comp time only duck typing. Meaning, if it looks like a duck and quacks like a duck, it's a duck. That only works at comp time. You have to know what you're going to do at comp time, but that's not really that big of a problem.
And that's essentially generics, right? It's like auto generics?
Yes.
Because it makes a different copy of the function for each one?
Yes. Zig also does have explicit generics, which is how ArrayList works. You pass it the type you're going to be working with. And then it generates a type of ArrayList based off the type you pass to it, which is explicit generics, whereas any type is implied generics.
So if that had an any type, would that still
So
work?
the difference is ArrayList is taking in a type. What you could have done is you could have a different function which takes in any type, which means it's a value to have any type. So that ArrayList is taking in a type as a parameter,
Oh, got it.
as opposed to a value as a parameter. So that's the difference between any type versus type.
Thank you.
So the problem with ignoring the fact that those ArrayLists are a kind of sort of type of polymorphism, the problem with this is that we're going to have to keep separate lists for every type of enemy. Anytime we want to iterate them, we're going to have to iterate those lists separately. Anytime we need to pass all our enemies to a function, we have to have a field for each and every one of those. And we're going to show why that is using some assembly. So this is x86 assembly produced by GCC. This is compiled from C. If you've ever used Godbolt, that's where this is from, which is why the lines are different colors.
You got a dark mode on Godbolt?
I do.
Oh, I don't have that. I'm living in 2020. You're in 2024.
What's Godbolt?
Godbolt
Power Explorer.
Yeah, it lets you compile things and then shows you their output. We are using compiled C instead of compiled Zig because Godbolt does not let you pass in options for the Zig compiler very easily, and so you can't do a release fast and remove all the safety checks. So we're just using C because C never has safety checks.
Are you
To
sure about
click.
that?
At least I
I
couldn't see.
use that all the time. I
Oh.
brought it up on my laptop too.
Well, I stand or I sit corrected.
Hey, we're here to learn. Maybe we could pull it up and you can show me what you're talking about later.
Yeah, for sure. Anyway, what these are is these are just identity functions, meaning they take a value of a given integer and they just return that same value back. Believe it or not, this is actually useful. It's used in functional programming, but I'm basically using it because it's the simplest function you can possibly have, more or less. So the important bit is on that third line of this first function. This is taking in an integer. It's reading in a value from one of the computer registers and putting it at an offset from the function pointer. And that offset is 4 places. That's 4 bytes. And if you look at the long, it is almost exactly the same. The registers it uses is different, but the offset is also different. It's 8 bytes. It's because an integer is 32-bit in C normally, and a long normally is 64-bit. And this is actually the only difference between different variables, essentially, and different types in programming. When they are stored just as integers, with given lengths and offsets and some padding and stuff, but essentially they are stored just as integers, which means if we can overcome the spacing and if we can overcome knowing the layout of what fields are stored where, we can adjust everything. We can use polymorphism, but we have to overcome those problems. And that leads to this point. Types are not real. Types only exist at compile time. Once something is compiled, there are no types.
It's like TypeScript.
Yeah. Except for everything. So what we are doing when we're doing polymorphism is we're just coming up with ways to tell the compiler what to do. Once it actually runs, the compiler doesn't exist anymore. This isn't Python, where there's some back-end process that takes up 1 million megabytes running at the same time. We just need to know what we're doing at compile time. Kind of already covered this, but just an overview. All types are comprised of integers. Their layouts are known at compile time, and or we have a way to process branching logic on the types at runtime. Let's look at a little bit more assembly for something called a union. A union is a type. Here, I'll show a union more or less in Zig real quick. A union is saying that we have multiple types and this variable is going to be one of those types. And what the union actually does is it takes up the full space of whatever the largest variation is going to be. So this is an example of a union from C that is either an integer or a long, like we saw. And as you can see, it takes up 8 bytes like the long previously, because an integer smaller than a long, it takes up whatever space the long is. In Zig, we do have a handy thing on top of unions, and that is a union enum, which means it actually will store type information that we can use at runtime. And it stores that as an extra integer just at the beginning of the storage, plus some padding. But that allows us to query the type when we're working with it. So using this exact thing, using the goblin and ogre we defined earlier, or the ogre we pretended we defined earlier in the goblin, we can create an array list. Now it's just an array list of enemy. And we can, here we're iterating to add, we're adding them to the same list. That's the syntax for creating a union in Zig. Technically where it says enemy, it could just be a dot because it'll infer the type at compile time. Just wanted to make it a little more explicit. And then we can have a switch on the type as we iterate over it. So we can pass them together and then just perform some querying on the type to decide what we're going to do. But this can get a little bit better actually, because unions in Zig can have methods, and we can actually move that switch into the union. And Zig also has a powerful feature called inline else, where since we're using a union of an enum, it knows all the possible variations, every type it could be, so it will actually write out the switch for you. Any questions on that or comments?
No, on that, but what was it God something?
Godbolt?
Godbolt, okay. I was trying to look that up, so I could look it up later.
Yeah, we'll have to bring it up again.
Oh, okay. So this works for as long as all of those types have an update function, this works.
Yes.
Okay, yep.
If one of them did not have an update function, you would
You'd have a compiler.
you'd have a
You're
compiler.
saying like basically the compiler writes out all the branches of the switch for you because it can know that they all have an
Yeah.
update function.
Yeah, that's what the inline
So
else
if you have
does,
like
yeah.
a huge union of things, it would save you a ton of time just to write this inline else. instead
Yeah.
of that. Okay, that makes sense.
And then if we want to iterate over this now, this is just the only iteration we need for any enemy type that respects the rules of having an update function. As a brief note, you may notice there are a few times where I have a capture and then I declare a var. That is because of some funny way. In this case, it's not strictly necessary, but in some other places, it can be just because of how Zig expects switches to be done on types.
Well, the
And
capture's
it's
constant, right?
It is. You can get a capture that isn't constant, but then that messes with switch statements sometimes.
Is the extra ending curly brace a typo, or is that something?
That is a typo. I apologize for any and all typos in my
It's okay.
presentation.
Not being familiar with Zig, I'm like, okay, what's that closing? Like,
I will tell you what it is. This is a screenshot that I took from a larger program, and I just accidentally grabbed an extra.
okay.
So if you're missing an update function on one of the union types, is it like compile time error or is it a runtime?
It is a compile time error.
It is compile time error.
That is one of the benefits of unions. Most of it is compile time polymorphism. It will query the type at runtime, but the stuff around that is all compile time. There are some problems with unions. Specifically one. Let's say Goblin takes up 32 bits entirely. But then Ogre takes up a megabyte or something crazy. Unrealistic, but any Goblin instance in this case would also take up a megabyte. That is the downside. In terms of speed, this is fairly fast, but you do pay some overhead. Also, by having a union of an enum, you also pay a price for every instance of it in terms of the tag. And the tag is just an integer, but will often have padding inserted by the compiler as well, which bloats the size. You can overcome that if you don't use a tagged enum and you keep track of the type elsewhere. I'm not going to show that here, but that is an option that I wanted to call out. So if memory is your main important focus, this might not be your best option. The other options all basically boil down to different types of pointers. So everybody knows what a pointer is, knows how they work.
Roughly.
You're all smarter than me, so I...
I am ish on that, but I'm like, yeah.
So
Ish.
a pointer, instead of storing the value, just stores where it is in memory. And so here we have two more identity functions. This one takes an integer pointer and returns it back. The second one takes a long pointer and returns it back. But if you look at the code, it is actually entirely identical. The reason for that is because pointers on 64-bit systems, generally speaking, always going to be 64 bits long. Doesn't matter what type it's referring to, always going to be 64 bits long. And so you end up with these functions being exactly identical. So any strategy that uses pointers is not going to have the overhead of a tagged union. And it is, however, going to have a penalty in terms of speed, because anytime you need to perform logic, you're going to have to follow pointers, which are usually going to be stored on the stack, on the heap, which is slower than the stack. They could theoretically be on the stack. They're generally on the heap. And also you open yourself up to cache misses. The first type of solution using pointers we're going to be looking at right now is something called any-opaque. What that means is we're going to create a pointer, and at compile time, not just at runtime, but at compile time, we are going to forget what type it is. The compiler will not keep track of the type, which means it will not error on any type-specific logic until you run it. So here's how you do that. Say we've got a goblin here. We init the goblin. We create that pointer using pointer cast. Pointer cast will figure out what type it's supposed to be based off the type hint. Here's any-opaque. And then if we want to get it back into a goblin, we can just reverse this using align cast, which just makes sure that the data is aligned properly. And then another pointer cast to take it back. The problem with this is, as you can see, bringing it back to the correct type is hard-coded. The compiler will not be able to do this automatically for you. So there are a couple ways to overcome that. One, you could have another list array storing the types, and then use that as logic to figure out what to do. Or we can go back to essentially a tagged union, but this time instead of storing it all together, it stores a pointer. So we have an enum that declares certain types, and we have a structure that stores both that enum and the any-opaque pointer. What we can then do is switch on that stored type and then perform the logic. You cannot do an inline else for this. You have to manually code this. But you do not have the overhead of passing around so much memory every time. Any questions on that? Is that all straightforward?
No, it's not straightforward. So,
I think you should go back to the previous slide for this explanation you're about to give.
so my question would actually be going back to kind of first principles here. So anytime I see a lot of metaprogramming, I start to think that either this is something that you need to do for really, really highly specific optimizations, like what you were showing. Like in general, metaprogramming bad, right? The use case. Well,
I agree.
The use case that you showed, I think, like you were highly tuning something, right? You are taking advantage of every little hack to tune the hell out of it until only the heaven is left.
Yeah.
Right? But in this case, the example doesn't quite make sense to me, because wouldn't we just have an int or an enum that is a type enum that's, can be goblin or can be ogre, and then I would just have my struct would be an enemy struct. Why would we not use simpler means to model this rather than modeling it in a way that requires so many tricks?
So essentially, because the simplest way you can get away with doing this is using a tagged union.
But what I'm saying is goblin and ogre are going to be pretty much the same, right? Like I don't remember if I saw what was different about goblin and ogre.
I think there's the potential for that.
There's the potential to be different. So for instance, they could have different functions. So say for instance you've got update on goblin, and all the update on goblin does is update its position. But on ogre, it's also got 5 other methods it calls. You can either embed that as a million if statements in the function, or you can use polymorphism. There is an argument to be made that the if statements are the right way to go.
Yeah, okay, I see what you're saying there. I would want to see it. I wish I could see an example of it with it's a little bit more easy to latch onto, because yeah, I just get scared when I see things like what you're showing, because it's very clever, and that means that it's going to be difficult for me to remember it in 6 months, and it's going to be difficult for someone else to read.
That's fair. A fair, I think, call out is, even though this feels clever, these methods are actually how a lot of higher level languages will handle polymorphism. They just hide it.
Yeah.
And so if you want the same benefits that those languages enjoy in Zig, you do have to do it manually. The good thing about that, though, is that you get to choose which compromises you make. And it is always going to have some compromise. There's always going to be the compromise of complexity, and there's always also going to be other compromises on top of it. The good thing about Zig isn't that you don't have those compromises, it's that you choose which ones you have. For instance, C++ will use any and all of these methods I'm going to show today, including the ones we've already gone over. It will not tell you which one it's using, and you cannot tell it which one to use unless you basically repeat what we're doing in Zig.
So this fulfills the promise of no hidden control flow.
Yes.
Okay.
It is also, I think, worth pointing out that for a lot of programming, this is entirely unnecessary. The reason I used video games as an example is because those are probably the most polymorphic programs that exist.
Yeah, I feel like the chess example in college was a pretty decent example. I might try rewriting a chess game to see if I can do it without using polymorphism.
You could. That's definitely something you can do. So in C, for instance, you either use this, programmers in C will either use their equivalent of any opaque, which is void in C,
Right.
but void means something else in Zig,
Right.
or they will just store the data that they need to process and then use control logic.
What does the @ sign mean for pointer?
That's turning that variable into a pointer.
No, that
Well,
at
basic.
is, it denotes.
Oh, sorry.
It's a built-in to the language, so it's a
Okay.
built-in function.
Okay.
So that's how you know.
Yeah.
that, yeah, it's built in Zig, it's not.
And the ats are also all comp time, are they not?
No.
Okay, no.
I think there's built-in functions.
A lot of them are comp time, though.
Yeah.
Yeah, I think there's, coming into Zig being Java and Kotlin my whole life, I think this also threw me off and seemed wrong. Like it seemed like a lot of work to do something, but as I got into it more, I realized, oh, this is all happening when I'm writing it in Kotlin, and probably in a way worse way. Here I just get to choose do I want memory or do I want performance, or like you get to choose your options instead of just like whatever Java thinks is best. But it just feels like a lot of work because you're so used to something else doing all the work for you. So I think that like caught me off guard for the first little bit.
So I'm used to programming in Go, and I learned C and JavaScript at the same time, so I don't write JavaScript like a madman. I write JavaScript like someone who would have used Go if it had been around before. So I don't find myself needing to reach for complex patterns very often. Like, I know that in school they always try to teach you like the most academic way to do things, but in the real world, for me, I feel like very rarely do I have to reach for something as complex as like, you know, multiple inheritance hierarchies or whatever. So that's where my you know, comes from, because I'm like I would find some simpler way to do it that doesn't require doing it, but maybe I wouldn't. I don't know.
You know, you could. These are objectively not the most obvious ways to do things. I think they do have some benefits, though.
Yeah, I sorry, I didn't mean to derail, but I am curious. Like, is there something else that would be more, quote, idiomatic?
All idiomatic to Zig. So, I mean, just to defend my presentation a little bit here.
No, I'm sorry. I don't mean to.
Every pattern I present here actually occurs in the Zig standard library.
Oh yeah.
So.
Yeah. I don't doubt it. They do all sorts of weird, crazy things in every standard library. Like Go has so much non-Go code in the standard library because they're doing all these weird tricks. And
I would say the any opaque, this one we're looking at right now, is probably the least idiomatic Zig that I've got here. Somebody else can correct me if they feel differently.
I've never used any opaque, so I don't know.
You use it when you need to.
Yeah.
I used it several times. But avoid it.
Okay. Let's go on to V-tables, which are another strategy that use pointers, and this is the last strategy we're going to look at today. But instead of hiding your entire type behind pointers, you are only hiding the things that need to change. So anything that is going to be shared across all instances is going to just live in a struct, and functions that are going to change are going to be pointers. So for instance, if we have an enemy type with an update and a draw and then an X and Y coordinate, the X and Y are going to live inside the enemy struct, and the update and the draw are going to be constant pointers to functions. And you basically just put the function signature there, and it will accept at creation time any function that satisfies that signature. So here's an example. Goblin, the init function for this will, instead of returning a goblin, it will return an enemy type with the update of enemy and the draw of enemy set to its own update and draw. And this is most of the time the way classes work in C++. Not always, but most of the time. I'm not super familiar with how Rust works on the back end. I've been told it works similar. Let's say for our ogre now, let's say it actually has the same update function as Goblin, but has a different draw function. This is how you do this. This is inheritance. You could theoretically have, like AJ mentioned a minute ago, multiple inheritance where you inherit from multiple places. That is generally considered dangerous. I think here the fact that there is no hidden control flow in Zig does make it a little safer though, because you have to tell it where you're pulling from. It will not decide for you. So for instance, in Python, if you have multiple inheritance, it has a really arcane order in which it pulls priority for inheritance. Because we're doing this manually, there is no arcane order unless you create one.
A lot of JavaScript people say favor composition over inheritance. This is actually kind of more like composition than inheritance, because you get to pick and choose which ones you want.
And then for this, if you did have variables that you wanted that would be different for each class, you would need to hide that behind either an any opaque or something else similar. And then if we want to iterate over these, we are down to a simple iteration. Again, that asterisk is how you get a non-constant capture, which we can do in this situation. You will notice there is something a little bit funky with this for loop, and that is we are passing enemy to itself. That is because Zig does not treat a pointer to a function the same as a method. But there is a solution to that, which we'll look at here. If instead of storing the things directly, if we have a helper function that then calls the pointer function, we can handle that automatically because that helper function will be given the implicit self, and then it can just pass the self. That does require writing a little bit more code. Also, that update doesn't have to be in that struct there. It just makes it a little easier to understand and group together where you're going to put the pointers. It could just be a separate pointer with a different name, like update pointer or whatever you wanted to name it. And then this is just instantiating that. And now we can loop over it in a way that is opaque to the fact that it's using vtables.
So did that add another layer of indirection for the function call? Or is it still, was there any trade-off other than syntax in terms of like performance or memory or any of that?
I don't believe in this situation there's going to be that much of a penalty. The main penalty exists not at runtime, not at compile time, but at write time.
Okay,
It's just,
so syntax, or maybe I'm saying that wrong, but yeah, write time, dev time.
yeah.
The penalty is dev time. Okay, cool.
But I think the machine is doing something different now, right? Like in this instance, you have a function pointer and you're calling into that, as opposed to having a branch which selects which logic to do.
Oh, I thought, did you mean from my first example of the vtable
Yeah.
and the second one, or?
The non-vtable to the vtable.
Oh, the non-vtable to the vtable is a
Yeah.
big performance drop. So anytime you're using a function pointer in any way, you are going to slow things down tremendously. Unless your CPU's branch predictor works really well and does its job right, which is something you know more about than I do, but you can't really rely on that.
So when we say tremendously, now again, I am someone who primarily works in Go and JavaScript, so function pointers are the only thing that ever happens in the code that I write. What does tremendously mean?
So I timed this. I don't have the timings in a place where I can pull them up. But the timing I had was probably about a 10% slowdown. Now granted, the times themselves were really small because we're just talking about calling a single function.
Well, so the no-op is 10% slower.
Basically. But that's going to really depend. That's going to depend on how many pointers it's following. It's going to depend on what architecture you're using. But in general, you can rely on anything that uses a pointer anywhere, not just for functions, to be slower.
Right, right.
I remember correctly, I think it was Zig 0.9 that introduced vtables for the allocator in the standard library. I don't remember what I used before, but I do remember that they found this to be better than what they were using before. So I'll have to go look at that again.
Yeah, this is basically, I took the allocator example and simplified it. So that's where that comes from.
Performance or memory that they were trying to improve, but I do remember they found vtables were a good solution in that case.
Yeah,
They are-
with something as complicated as the built-in allocators and the fact that they can vary quite substantially, you would pay a big padding penalty to using a union, and also using vtables does make it easier for somebody to come and plug and play and integrate their own allocator. If you wanted to use a union for that, you would have to edit the source code of the standard library, which is, some people like doing that.
We don't have comp time monkey patching?
So those are a few strategies for polymorphism for anybody who wants to do polymorphism. like I said, the main trade-off for any of these is going to be whether you prioritize memory or speed. Definitely use, I would say if neither of them is all that important to you, use a tagged union. That is the most built-in feature to Zig for a small program that you're just going to use yourself. Just use a tagged union. It handles things fairly nicely. You have the inline else that makes things fairly easy when you need to branch on the logic. If you do need any kind of inheritance, if you do need to prioritize memory, that's when you would reach, preferably for a vtable, but failing that, you could also use an any opaque if that meets your needs better. Is there any questions, comments, concerns, jokes, insults?
I have Zig questions. Could you go back a few slides?
Yeah, which slide?
Back more. That one.
This one?
Yeah. Nope. The previous one. That one. So enemy, basically the init function that's returning the enemy is the dot update. You have to include the dots. I assume that's like defining an object, but could you have other things than dots? Like, I know in JavaScript, if you were defining a class, you wouldn't have the dots in there, but you could add like a hashtag to mean it's a private variable. So could you do things like that? Or is it like the dot is the only thing allowed, and then I guess my question is, why is it required if it's the only thing you can do?
I think if I were to try to read Andrew Kelly's mind, which we are both Andrews, so maybe I can do that, it would be for situations like this, where you need to make clear what is part of the struct and what is a variable outside of the struct. So like dot update equals update.
It's like this dot without the this, which is much nicer.
Yeah, I would guess the same thing as you, just so you don't have to have like to rename things, weird names, just so you just have an update and an update.
Okay. That was my question. I was just curious about that.
I love debating syntax.
I'm not debating
So
it. I'm just
actually-
like curious, like why?
Okay,
why?
from the parser perspective, does this make the parser simpler?
I think I may have heard something about how it can help. I don't know.
Okay, I was just curious, because I could see, well, one of the problems in JavaScript is that there's a lot of ambiguities, especially as they keep on adding more to the language. So the parser gets significantly slower because there's more conditions where it's non-deterministic what is going to come next, and so you have to go down the path until there's an error and then back up and then go down the next path.
Yeah, in Zig you don't have to do that ever in the parser. It's designed to be easy to parse. So.
Well, I mean, that's one of the benefits when you design something.
Yeah.
JavaScript didn't get
Hey,
that.
JavaScript was built in 10 days, so, that's better than I could do in 10 days.
It wasn't built in 10 days. It's been built in like, what are we going on, 3 decades?
Well,
they won't stop building it.
That's fair. It was built in 10 days, and then a certain large technology conglomerate ensured that its design stayed bad.
Yeah, I wish Microsoft would just get off the committee.
And now it's too late. Now it's like C++, where they can't change any of the features or remove anything because there's 30 years of programs. More than 30 years of programs.
Come to Utah Stack JS sometime. I'll present on my thoughts on that.
That's next week, right?
Actually, it is next week.
Okay, any other questions?
I guess not a question, but coming back to the dots, I just checked. That is also something that's in C++. I didn't check if it's in the other languages, but it also could just be syntax inspired from another language.
Probably C.
Could be.
It was weird when I first saw it, but I like it.
I do have to admit, sometimes I forget the dots and then I get a compile error and have to figure out where I forgot the dots. Like when I was Like, the classic semicolon problem. Which, to be fair, again, to make fun of JavaScript, JavaScript's insertion of semicolons, if you forget them, is inherently buggy.
Yes, I
Don't have
am
my
aware.
work. I just leave those off.
Hey,
Then I dangle comments at it.
But while we're off topic, if you use the keyword void, whenever something could return a value but doesn't return a value, not only is your code more readable, except that nobody knows that void exists in JavaScript, but if they did, then it would make your code more readable. But also, then you can not use semicolons and never encounter a circumstance where it would cause a conflict with the parser.
I think that the fact that you can either not, forget type safety, the fact that you can either return or not from a function is JavaScript and Python's worst feature.
Indeed. Well, all right. Shall we put our hands together then?
Yeah.
Well, thank you very much. I somewhat apologize for my critical nature.
No apology required. No apology wanted, AJ.
Okay, good. I appreciate your presentation, and I'm looking forward to the day when I have to fight this battle and this information saves my life.
I will say my largest project I have is a server built in Zig, and the closest thing I have to this is using any type.
What kind of server?
Mostly for static file delivery,
Okay,
but it does have the ability to do dynamic content as well,
okay.
in theory.
I've actually been wondering about that because the few times I've looked into Zig, I'm like, I don't even know where to start. Like, if I just want to do I'm mostly working in web, so I'm like, how do I do a simple, web server? And I don't even know where to start with that, so, are any tips on that?
Yeah, so you can look at my code. It's on my GitHub repo. Its name is Zoe, Z-O-I. It is basically just meant to be a minimal HTTP server that you can then build any functionality you actually need on top of. It will handle static content delivery automatically if you just compile and run it. But there's a lot of things it doesn't do by design, so that you can just look at what it does do and change it. I think it's fairly good. It's a lot simpler than the standard library HTTP server. It also predates it, which is why I made it. But
Cool.
yeah.
So Zig standard library now has an HTTP server. See, I haven't looked into it long enough. I'm pretty sure there may not have been a standard library when I first looked. How long has this standard library been around? Yeah.
It was introduced for the package manager, if I'm not incorrect. I think it's only been around for less than a year.
Okay, that would explain it. I'm pretty sure I looked and there were maybe some awesome Zig references to HTTP servers. And I don't know what this is doing.
I know there's a bunch of third-party ones.
Okay.
Bamboos and others.
Probably the most popular one is something called Zig Zap. And that's an entire full stack framework, kind of like Leptos, if you've ever looked at that in the Rust world. I think it has a similar ideology behind it.
Well, I want to present to you our gift for being our presenter.
Thank you.
If you have too many pocket knives, there are some other options as well.
No, I need a new pocket knife. I'll take
Would
this one.
you like me to open that for you? with
Yeah,
the
because
knife, since
you need a multi-tool
knife?
to open the multi-tool.
Yeah, and wait, did we get you a presenter gift last time? Yeah. Okay, good, because I thought that maybe
Pretty
I
sure
had-
he made the same joke about multi-tools that I did.
Oh, okay, yeah.
I think you got it the wrong way. You stole my joke, not me stealing your joke.
I said we used the same one. I didn't say who stole from who. I was inspired by his joke. We'll say that.
And then,
It's better.
same piece of advice, you might want to put a little bit of beard trimmer oil or machine oil or something, just like a drop on it, and then open and close each of the mabobs about 10 times to loosen it up, because it's really stiff the first time, but once you've used it a few times, then it loosens up and it's nice.
I got some WD-40. I know how it goes.
Actually, I don't think WD-40 would be a good choice because it the WD stands for water displacer, and so it is actually like alcohol. It is a dehydrant. Or no, it's not just a dehydrant. It's aquaphobic. So the reason that it was created was to get water out of joints before you re-grease them, and it temporarily works. But if you look like long term, it's something you put WD-40 on. It's not what you think it is. But
Interesting.
WD-40 does have a silicone spray, and that would work. Well, I mean that's beer trimmer oil, machine oil, silicone spray. That's all pretty much the same thing.
Just learned a bunch of new things.
I get a new hobby every year, and so a couple years ago, I've always been in a four-wheeler since I was a kid, but I bought a junker four-wheeler and I fixed it up, and so I learned all about different types of greases, and yeah, but she runs well, so. All right, I will go ahead and end the online portion of this. If there's anybody online that has a question or a comment or anything you want to say, you've got 20 seconds. And I'm going to factor into that also that there's a 15-second delay on the stream. And then we're going to let Andrew do whatever he wants to do within the bounds of reason and the law, which are not always mutually inclusive. Within the bounds of reason or the law.
I can choose one.
We were promised a knife fight, so.
Hey, and we've got knives. Who else wants a knife?
Spencer didn't think this through unless he brought like Bowie.
Well, wait. I think that both falls outside of reason and the law. Okay, I don't see anybody on the stream, so I'll go ahead and end it.